Hey guys, Mr. Mailhot here. Hopefully everything's going okay. Let's go through a few problems together. We weren't able to get to them in class of graphing trig functions by shifts. So this is the worksheet we started. Go ahead and flip over to the back. Let's run through the first three on the back side here, okay? All right. So we're dealing with the sine function. Here's a good tip. First, sketch the basic sine function, the non-shifted one. And remember, it originates from that unit circle over here. And remember, for sine, the points we use are the y coordinates of each of these 4 points around the unit circle. And actually, we use 5 key points to be able to plot our graph. You might be wondering, why do I say 5 when we only have 4 around the unit circle? Well, it's because we go around one time, starting here. At 0 degrees, we have 1, 90 degrees 2, 180 degrees 3, 270 degrees 4, all the way to 360, there's our 5th point. So at 0 degrees, the y value there is 0, right? It's not up on the y-axis also. That's the starting point of our original graph. And look at your notes, right? It looks a little something like this. All of the y values are on your trig graph, right? At pi over 2, it's 1 because we're 1 up on the y-axis. At pi, we're back to 0. At 270, we're down to -1, and around all the way back to 0. So that's the basic graph. That is not the graph of this one. This one is shifted. How has it been shifted? Well, remember, we've got our H and K. So it's been shifted to the right. Remember, it's like the opposite of the sign in there. To the right, pi over 2, and up 1. So let's take care of that. We're going to shift our whole graph up 1 and to the right, pi over 2. Now, notice the scale here. Pi over 2 corresponds to 2 grid lines. So that means we're moving 2 grid lines. So every point on here is going to move up and over, 2. Up 1, up and over pi over 2. So that means move each of these 5 points. Move this one up 1 and over pi over 2. There's our new starting point. The one that was right underneath it that I just covered up, move it up 1 and over pi over 2. Or 2 grid spaces in this case. Or the one that was at 0, pi, and 0 down here, move it up 1 and over pi over 2. Here. Up 1, over pi over 2. And the last one that was on this 2 pi, up 1, over pi over 2, and we're going to estimate a little bit. And there is our shifted sine graph. Shifted up 1 on the y-axis from that k value, and to the right, pi over 2 from that h value inside the parentheses. Now, we remember like these continue on in both directions, but we only need to graph one curve per now. This midline and starting point is another way to help you get familiar with the amplitude and shift. Midline of this graph, well, in the original graph, the lightly sketched one, it was at 0. It got shifted up 1, so that means the midline is up 1. Y equals 1. If I draw a line through y equals 1 like this, it goes right through the middle of my graph. The starting point, well, where did we start at? Not 0, 0, like the original graph. We start up 1 and over pi over 2. As an xy coordinate, x first would be pi over 2, comma 1. Notice how these pieces, this one that got shifted up and these 2 here, are both in the equation there. Let's do another one. Okay, number 2. 1/2 sine x minus 1. Sine of x minus 1. This 1/2, remember that's the amplitude. The distance from the midline, the midline, to the highest or lowest point on the graph. So again, I always like sketching the basic trig graph. It's a good practice. The basic sine graph or cosine if you're doing cosine. It's good practice. So how's this one been shifted? Not stretched, not amplitude, but shifted first. Well, it just says down 1. So these 5 points for the basic parent function, the sine graph parent function, are all going to be moved down 1 from that k value, down 1. So this one that's at 0 is going to go down 1. This one that was at 1 is going to go down 1. This one at pi is going to go down 1. This one at 3 pi over 2 is going to go down 1. This one at 2 pi is going to go down 1. So now we kind of shifted down here. That's not our graph though. That's just, if we were to just graph this, it would match this graph. But this 1/2 is going to shrink it. Right now, the midline goes right here to -1 because we got shifted down 1. There's our midline, -1. Y equals -1. This one that we just lightly sketched, the amplitude here is 1, right? That's how far from the midline up that shows. But this says the amplitude needs to be 1/2. So, cut all of these points in half. Instead of going up 1 here, go to 1/2. And it was on 0, that's okay. Instead of going down 1, go 1/2. So we kind of squished our graph by 1/2. So instead of going on this lightly paced one, we're going to go a little bit flatter. Still goes through that midline at the same points, just a little flatter. So this right here. And again, it would continue, still not like kind of flattened out because of the 1/2. But this much is okay that we sketched here. That's totally fine. The starting point, well, let's see, where did we shift it down to? It didn't get shifted to the left or right at all, so just down 1. Starting point would be 0, -1. All right, one more. Cosine. Hey, cosine. Okay, let's graph the basic cosine graph. Think about the unit circle again, right? Going around the unit circle, it's the x values at each of these points. The x values. So at 0 degrees, that's out 1 on the x-axis. At 90, that's at 0. At pi, well, that's back -1 on the x-axis. Back up. We looked at these in class, right? You guys plotted points, so you're a little familiar. Here's the basic sine graph. This is not the graph of the function that we're given, but that's the basic one. We're going to shift it, and I think we stretch it too. Has it been shifted up or down? No. No, there's nothing here. So, not shifted up or down. Not. What does this mean? I'm giving you time to answer. Move to the left, pi over 2. So each one of these points is going to move to the left, pi over 2, which on these graphs, again, it corresponds to like 2 grid spaces. So we're moving left, pi over 2, or left 2 grid spaces each one. It also got stretched now. So now the amplitude isn't 1, right? This basic one, the amplitude's 1. The distance from this midline to the highest or lowest point is 1. This one says it's 2. The one before it was 1/2. When it was 1/2, it got skinnier. When it's 2, it's going to get taller. I don't know, skinnier, flatter. It got flatter. Now it's going to get taller. So our new starting point has been moved back. Our midline has not changed, right? We didn't shift up or down. So this distance needs to not reflect, that's a bad word. This distance needs to be the same as the amplitude that's shown here. Right now it's 1. In order to make it 2, we got to go up a little more. Now that has a length of 2, right? This point on the x-axis got shifted back to pi over 2. This lowest point got shifted back pi over 2. But still, we need to stretch it to 2, or down to -2, so that the distance from this midline to that lowest point is going to be 2. This part, move back, power of 2. This one, move back, power of 2, and stretched up. Okay, we got a lot of dots going on. I know I drew a lot, but here's what your graph should look like. It's a little skinnier, still that U-ish shape. It's not a parabola. It's a cosine graph, cosine curve. Notice the midline is still the same, and because we stretched it, this distance is now 2, just like it's 2 here and 2 there. You don't have to draw these lines. You don't have to label that, but it helps me, and maybe if you sketch it lightly, it might help you also. Okay, there's 3 examples for you to go along with. We're going to have another video here soon. The rest of these answers are on the board in the classroom, so check those out. All right, guys. Hey, there's the bell. Have a great day. See you later. Remember, we're mathematicians. We can do anything we want. See ya.